This is a step-by-step guide for principal component analysis and exploratory factor analysis. Here we have a data set with 200 participants with measurements in 12 items. So we are going to run a principal component analysis to determine what number of components can explain the data, and exploratory factor analysis to determine the number of factors to explain the data. Very, very similar analysis. So first we can do some statistics. We go to descriptives and we copy all the items into variables, and we get the descriptive statistics, mean, standard deviation, minimum, maximum in each of the items. Then we can do a bit more of descriptives, and we go to regression and we go to correlation, and that will give us the correlation matrix. So again, we select and we put all the items, and we've got here the correlation matrix, the correlations of all the items. And then we go to the factor module, and we start with principal component analysis. And we do the same. We select all the variables and we move it to variables, and now we get the results. Now we are going to choose eigenvalues here and to put eigenvalues above 1 as the threshold to keep the components. Now here in rotation, in the rotation I explained in the masterclass is orthogonal. That means that the principal components remain perpendicular. But you can relax that requirement of doing rotation that keeps the components perpendicular and use an oblique rotation in which you don't need to be, the principal components don't need to be perpendicular. So that means that they will be a bit more correlated if you allow for oblique rotation, and one of the oblique rotations is Promax. Okay, so the other thing is that you'll see that not all the loadings are presented for the factors, and that is because in output options here we've got 0.4 as threshold to show or not show these the factor loadings. So factor loadings lower than 0.4 will not be shown, but we can remove all these and put 0, and if we put 0, all the component loadings are presented. Uniqueness is the variability of the items that cannot be explained by the components. We've got the components characteristics as well. For component principal component 1, the eigenvalue is 4.6, so obviously we keep always the first one. And then the principal component 2, the eigenvalue is 2.97, greater than 1, so we keep it, and it accounts for 0.248 of the variability of the data, and the cumulative explanation of the variability of the data is 0.6338. Now, if we go to output options, we can have correlations between the factors, so between the two components, the principal component 1 and 2, which is negative 0.0338. If we take path diagram, we get a diagram in which the items, the arrow goes from the items to the components, and the script plot that describes the decision making on what components to use, and the first one and second one are below the horizontal bar, and the third one is, the first two are above the horizontal line, and the third one is below and the rest are also below. So then only 2 components are kept in the model. So now I'm going to quickly do the same with exploratory factor analysis and then wrap up. All the variables are moved to the variables box, and then we've got factor loadings. And again, if I go to output options, I can reduce, let's say, let's not go to 0, 0.19 as threshold, and didn't change much. None appeared. And we can go a bit lower, and then they start to appear. Okay, so then we also do a factor correlations, which shows the correlation between factors is 0.08. And then we do the path diagram, and in this case the arrows go from the latent variables or constructs to the items, as opposed to principal component analysis, in which the arrows go the other way around. And the scree plot what corroborates what we already seen, which is how to make the decision of keep or remove components.